In Chapter 3, we'll be doing the first 6 sections, and this will be the bulk of our 1110 course. And in this section, we'll do a little bit of review, and then looking at a few new things. Some things from our Math 1103. We'll look at the polynomial function. Here it looks quite detailed, but it's really sort of easy. And graphing techniques, completing the square, the vertex formula, and the quadratic model. Well, what is a polynomial function? Well, normally it's a series of terms where in the usual case we have a power of x that will be decreasing until eventually the last power of x is 0, and that would just be a constant. So here they're giving it in a very formal mathematical way. Now let's look at some of the examples they're giving. A polynomial function where the function of x equals 2. Well, this is called a constant because 2 has no variable. Now, if your constant is there and you're introducing, whether it's there or not, it could be a 0, but here you're introducing a variable, and the variable is to the first degree. There's an exponent of 1 there. We say that is linear. And another significant term, the leading coefficient. That is, when it's in this descending power form or degree form, the constant on the first variable to the highest degree, that is your leading coefficient. So again, this is in descending order, but now our variable is to the second degree, and we call it quadratic. And the leading coefficient is 4. Now in this one, we see the variable is to the third degree. This is cubic, and the leading coefficient is 2. Now here our variable is to the fourth degree. Again, doesn't appear to be a leading coefficient, but anytime you have a variable, there's always a 1 in front of anything. And we just don't write the 1. So the leading coefficient is 1. Now, here we see the function of is equal to 0. This is what is referred to as a 0 polynomial, and it has no degree. Now, the one that we're going to particularly work with in this section are the quadratic functions. That is, the degree is 2. And we had said many times earlier that the standard form of the quadratic, if you take away the equal signs, this is an quadratic expression. If you're going to equal it to something, often we see a 0 here, that this equals 0. This is called the standard form of the quadratic equation, where this expression equals 0. And they're giving some qualifiers. A and B are real numbers, as well as C. But C, or I should say A, cannot equal 0. Because if it equals 0, then it's not quadratic anymore. It's just linear. Okay. Now, one of the basic formulas we've been looking at in previous sections as well is, remember, we can substitute this with the letter y. Y equals x squared. And we said this was a parabola, which they are describing here. And if you plotted some points, you would end up something like this. Now, the domain of this, in terms of x values, is from negative infinity to positive infinity. And they are also saying the range here, the y values, it would start at 0 and then go to positive infinity. So all of this we have said before, and I think we showed it in section 2.6. Now, a parabola or parabolas are symmetric to in this case, the y-axis, as we saw in figure 1. And this y-axis, here it's a dotted line, but in the y-axis itself it's a solid line, is the axis of symmetry. Now, there are a few techniques that we're going to introduce and some special formulas, and we'll get to this one in just a moment. So the dotted line is the axis of symmetry, and the vertex, when it opens, your parabola opens downward, is your highest point of the parabola. And you'll see another term associated to this is the maximum. We talk about the maximum a little later. That would be its highest point. And then we have, when it opens upwards, we find that the vertex is the lowest point. And later we'll see it's often referred to as the minimum. Okay, some vocabulary, and again, if you're taking notes, I would be writing these, making little sketches. These are your study notes, where based on your reading of the textbook, and later hopefully what your classroom teacher is presenting, things that are significant. Now, in 2.7, they did graph this and said the graph of any quadratic function can be compared to this basic one, which is sort of similar to this, or in figure 1. And if we were to put it in this form, which is sometimes referred to as the Vertex Formula, a couple of things are going on. So we're saying that most quadratic equations can be put into this form, and we'll be showing you that technique here shortly. But what does all of this mean? Well, they have it all laid out here nicely for you. Here we have, of course, our x value minus h. That was the other x, you might recall. And then this k was a y value. Now, a is what we might factor out of this. And this a determines whether your parabola is going to open downward or upward. Any idea what that might be? Well, if your a is negative, it's going to open downward. If a is positive, is going to open upward. Okay, a couple of little things. Now this H, you may recall, causes your horizontal shift. Remember, if this is a -2, it's going to shift 2 to the right. If it's a +2, it's going to shift 2 to the left. So it's opposite sign here. And then K was your vertical shift. In a sense, that was your y-intercept, if it's on the y-axis. Again, if it's shifting, it's not on the y-axis anymore, but it's going up or down to that particular y value. Okay, and here they're also telling whether you're going to have vertical stretch. If this is a 2, 3, 4, if this is less than 1, you're going to have a vertical shrink. All right, some things that we're going to now look at. Now, in letter A, B, and C, we're going to take a look at these functions, and we want to compare what's going on. And they want you to do so by plotting points. So let's take a look at A. Here's our formula. Now, when we plot our points, we can look at the graph to see, and keeping in mind our A value out here is positive, so it's going to open upwards. And we look for our vertex. Our vertex will be our lowest point, which is a -6, and x is a 2. So there's our vertex. And our axis of symmetry then, by the way, is our x value of the vertex, which will be 2. X equals 2 is a vertical line. That's your axis of symmetry. And then we also have a y-intercept here at -2, where x is 0, y is a -2. That's our y-intercept. And then we also have x-intercepts here that we don't know their value, but this is what the graph looks like by plotting. And if you had a graphing calculator and you put this equation in there, this is what it would look like. Now, when we do letter B, a number of things are happening, and we'll use this picture to illustrate it. Here, this is y equals x squared is our reference blue line. Y equals 1/2 x squared. Notice that you have a vertical shrinking, that it's going to go down lower. And if it were a -1/2 x squared, that would be the reflection of your pink line to this blue line. And here they're showing what it looks like in a graph. Going on to letter C now. Here they have it in our vertex formula. And keep in mind then, our vertex is going to be the opposite sign of our -4. So our x value will be a +4. +4, 3. +4, 3. Right there. And since our A term is negative, it's going to be opening downward. So again, we're comparing it to a -1/2 x squared, where the vertex would be at the origin. Here we're shifting this over, and then raising it up to a positive 3. And our axis of symmetry again would be our x value, which is the opposite sign of this, we said. Here it's -4, where our x value will be a positive 4. So a number of things going on, and here the range and domain are illustrated, and I believe we are familiar with that already. So we're going to look at this formula again, which is referred to as the vertex formula. And we have a function is equal to a, x minus h, the quantity squared, plus k. Now, we can convert standard form into the vertex form. And that's something we're going to be doing by using this process of completing the square that we looked at a little bit in a previous section. So we'll start off with this. So here we have a quadratic expression, a trinomial, that we want to put into the vertex form. And we're going to do so by completing the square. So there is a series of steps, in essence a recipe to do this. And it's similar to what we had before. We're going to take our c term, which is 7, and take it outside, in a sense, a parenthesis. So there's our parenthesis of our a and b terms. We've taken the c term, put it outside the parenthesis. Now let's look at it here, item by item. And I'll use my pen here, which I haven't been using up to now. There we go. So let me write this out for you. And this is all listed on the previous page and continued here, but I'll show it to you in action. So there's our quadratic. First thing we're going to do is take out the a term, the b term, and our c term. I'm going to put this part in a parenthesis. C term we're going to put out here. So again, these two statements are equal. We're now going to complete the square by taking half of our b term and squaring it. I'm going to put that down here. So we have our x, a negative comes out, and half of this is 3. Now to complete the square, we have to square a -3. That gives us a +9. But to keep this statement true, since we've added 9 to our parenthesis here, we have to subtract 9 out there. So again, all of this is equal. Now we factor this, which I've done already in this technique, and we now get a -2 out here, which is what they have right there. So now, what is my vertex? Well, remember we said the vertex was h, comma, k. And what is my h value here? Remember, it's the opposite sign. So it would be a 3. And then this is my k value, a -2. So when we were to plot our parabola, our vertex And since it's opening upwards, is also our minimum is a negative 3, 3, negative 2. There it is right there. Now our axis of symmetry is x equals 3. Whatever our x value is, that's our axis of symmetry. So this process is one that you're going to be doing in your practice and quiz me. So again, this was sort of an easy one, where you started off with this in its standard form of the quadratic expression. We took our c term, put it to the other side. We completed the square by taking half of b, squaring it, getting our new c term, a plus 9. But to keep this equivalent, we have to subtract 9. This gives us a negative 2 and identifies our h value, which is opposite sign of this, a3. And this is your y value, negative 2. I remind you, as you read your online textbook, as I'm doing here, they're giving you a video of how to do this problem, and that's often helpful. So here we have the quadratic expression. Notice our a value here is a negative 3. This would result in a parabola that's going to go like so, opening downward. But we want to find our vertex and our axis of symmetry here. Now we do so by completing the square, and here they show it in great detail. So let me talk you through it. You're going to factor out a 3 from each term. Well, before you do that, you're going to take this positive 1 and move it out here. Use your parentheses and then factor out the 3. You're then going to take half of b, which is 1/3. To complete the square, you need to multiply or square 1/3. That gives you 1/9. Now keep in mind this negative 3 also comes out here as well to this. And here, where you've added a 1/9 here, you have to subtract a 1/9. And this one becomes a, notice we can cancel out here, and this then becomes a positive 1/3. And we have to add it to this 1, which we're going to make 3/3, and that's where they get the 4/3. So you now have it in the form of the vertex formula. So this is h, and this is k. So what will your vertex be here? Well, your vertex is going to be the opposite sign of this, which is a negative 1/3, and your k term, which is 4/3. So there is your vertex. Now, what is your axis of symmetry? Well, it's this dotted line, which is x is a negative 1/3. Now, they also want you to find your x and y intercepts here. And how do you do that? Well, that's what we're going to show you. I'm going to have to move the page up. Remember, if x is 0, whatever your y value is, that's your y-intercept. So we take our original equation, x will be 0 here, x is 0 there, our y-intercept is 0, comma 1. There's our y-intercept. It's at 1. Let's go on. And then if we take this, divide everything by a -1, reverse the signs, and equal it to 0, now y is 0, we factor it and we get these points. Now in some cases they won't be nice points like this. So how would you find your x-intercepts? Well, in this case, they're going to show you one here in a few moments. You would put it in standard form with your a term being positive. So there's your a term, there's your b term, and there's your c term. In any other equation, this one factored, you would use the quadratic formula for that. And they'll show you that coming up here. So let's just move it up a little so we can see all of the things we've talked about, because they have it as a nice graph here. So there's the y-intercept right there, and there are your x-intercepts, there and there. And graph is not too great here, but that's what they're showing you. Okay, sometimes in the printing process it loses super accuracy. In MATLAB they do it very well. Okay, let's go on. Now what they're giving us this note about is that it's possible to reverse the process of example C, keeping in mind the vertex formula, and you know the values of the vertex. So you then can put this for your h. Remember, our negative value with a negative here makes this a positive. And then our k is this. And if you substitute, let's say x is 0, you square this, you get 1/9, and then eventually you get -1/3 equals 1/9 of a. A becomes 3. So now you have your first value here. And a number of things can be found from that. Now, don't get carried away. This is the vertex formula, how it is derived from standard form of the quadratic expression, and then eventually, and this is the thing, you don't have to know how to do all this. This is rather tedious. It's all there. But you end up with how to find the vertex. And it gives you this formula then. H, which would be our x value, is equal to a negative b over 2a. So if it's in the quadratic formula, standard form, you pick out your a, there's your b, it's just negative b, and remember this you could put the negative by the b if you'd like, of 2a. A lot easier than going through all of this. Remember, in your textbook they're looking to give you lots of detail, where in practicality you only need to know the n formula. So, once again, a little summary of what we're doing as we do the graph of a quadratic function. There's standard form of the quadratic expression. There's its vertex formula. And there's that special formula for finding the vertex. And K, remember, is what H would be. And K is your Y value. Now, a couple of things going on here, and I remember treating this in other courses where we look at the quadratic formula, and if we look under the radical sign here, we get the discriminant, they call this. This will determine the kinds of answers you're going to get. And there is to find your x-intercepts that I told you about. If this doesn't factor very well up here, then you have to use the quadratic formula to figure out what your x-intercepts are. And in some cases, we find the vertex using this little part of the letters up here, A and B, to find our x-intercept. And then in some cases, if this is going to be an imaginary number, there are no x-intercepts. That is, your parabola never gets to the x-axis. Again, lots of stuff going on here. All right, let's use the vertex formula now. Here it is in standard form. We're going to take our A, which is 2, and our B, which is 4. So keep in mind the negative sign is there. The B is 4. The A is 2. We get a negative 4 over 4, which is a negative 1. So our vertex is a negative 1. So if we put negative 1 into this formula up here, we get then x is 1, remember, and there's our negative 1. We end up with our y is 3. So remember we said we can substitute a y for this. X is a negative 1, and this becomes a 2, negative 4, 5. 2 and 5 is 7, minus 4 is 3. That would be your y value. So the vertex is negative 1, 3. Again, there's a little video that the company produces there. And here we're getting into the vertex of a vertical parabola is the highest or lowest point on a graph when it's in this form. Now remember, if A is negative, the vertex is going to be the highest point because this will open downward. If A is negative, your parabola will open downward, and the vertex is your highest point. If A is positive, then your vertex, I didn't do that one right, did I? Will open upward, and that is your lowest point. So we speak of maximum and minimum. Now here in this formula they're showing us something that's going to have a trajectory, so to speak, where it has a maximum up here. This is a negative 16, so our A term is negative. So let's check this out. So we're solving a problem involving projectile motion. You can read the specifics of this. We put it into our algebra, and we use our vertex formula. Again, this is negative, so we know this is going to be a maximum. So when we graph it using a graphing calculator, we see there's our maximum, and our maximum is at 2.5 seconds. It reaches a height of 200 feet. Okay? Now it's going to reach the ground over here around 6 seconds. That they'll tell you about as well. And for this one, we had to use the quadratic formula. And notice our time of reaching the ground is about 6 seconds. You do get a negative value, but we reject that. Okay, and then we have another model. Again, this would take a lot of time to go through all the detail, but we set it up as years and visits. Years and visits. And in some cases, I'm not sure we're going to be doing this, but you can put this information into your graphing calculator and hit the button, and they give you all of these results. So there it is. But again, figuring that out in the usual way without use of a calculator would be rather tedious. Okay, well, we kept it down to about 37 minutes. It's meant to be a review, not to replace your classroom study or your reading the textbook.